Okay, let's talk some about naming two of the most important functional groups that you'll be seeing this semester. We'll be seeing them an awful lot. Aldehydes and ketones. Now, in terms of naming these, the whole prefix, parent, suffix notation that you've learned before, we're going to be using exactly the same thing again. The main difference really is what do we use as the suffix for each functional group? Well, it's really quite simple. For ketones, it's simply -one, and for aldehydes, it's simply -al. And I told my Organic 2 students from last semester, if you don't remember the suffix for an aldehyde, think Bundy from Married with Children, and then, well, there you go, it's -al. Okay, that was supposed to be funny, but never mind. All right, so let's get on to actually naming these. Now, of course, the first thing we want to be able to recognize is when do we have an aldehyde and when do we have a ketone. So the one thing I hope you can remember from what you've seen in Organic 1 is simply this: a carbonyl group on the end of a chain, in other words, with a hydrogen coming off it, is always an aldehyde. And then a carbonyl group in the middle of a molecule, so with carbons either side of it, is a ketone. Okay, simple enough. So let's look at this guy. We're just going to follow exactly the rules that we have done before and say, well, okay, what's our longest carbon chain? Well, it's our only carbon chain, and of course it's 5 carbons. 5 carbons, of course, means pentane. So as we've done before, the parent name here is, of course, pentane. All right. So there's pentane. We know our suffix is going to be -al, and the rule we've seen before is if the suffix begins with a vowel, you have to lop off the last vowel of pentane, or of your parent name, so therefore the name here becomes pentanal. So a question therefore is, well, this is on carbon number 1. Do I need to put a 1 here? And the fact is, well, the aldehyde is by definition on the end of the chain, so the answer is no. So pentanal is all you need. Now it's different for a ketone because the ketone's not on the end of the chain, it can be anywhere in the middle of it, so in this case you do need a location number for where that carbonyl group actually is. So let's apply the same logic. Parent name is, of course, 5 carbons here, it's pentane. This means, therefore, if I take pentane and stick -one on the end, I lop off my last E and get pentanone. All right, so let me just write that on here. Pentanone. All right. But then we have to ask ourselves, well, where is the carbonyl group? Well, it's on carbon number 2 if you count from the right. So 2-pentanone. Now, is that the name of the molecule? Well, you can see, no, it's not. We are missing what's on this carbon. Of course, there is a bromine here, so this is where our prefix comes into play. It's going to be something bromo, and of course that something is 4, because relative to the carbonyl group, the bromine is on carbon number 4. So 4-bromo, 2-pentanone. Now, is that the end? Well, no, it's not, because we have our little stereochemistry here. All right. Now I'm not going to dwell on this very much, but the fact is, if you figure this out, the hydrogen's already pointing away from us. This is actually R4-bromo, 2-pentanone. All right. So basics of naming aldehydes and ketones. Let's look at this guy below. This is really just an exercise to make sure you find the longest carbon chain. 1, 2, 3, 4, 5. That's the longest carbon chain you can get. So do we have an aldehyde here or a ketone? Well, you can see we have an aldehyde. Again, it's pentanal, but it's a little bit different this time. We have to use our prefixes again because we have this and we have this, neither of which are in the parent chain. Of course, both of these are methyl groups. So if the whole parent name and the suffix is pentanal, what do you think the whole name would be with these 2 methyls on it? Well, of course, we need a di for the fact there are 2 methyls, so dimethyl pentanal. The aldehyde is, of course, on carbon 1, methyl on 2, methyl on 3, so therefore the whole name becomes 2,3-dimethyl pentanal. So 2,3-dimethyl pentanal, and hopefully this is relatively clear. All right, so those are some basics of naming aldehydes and ketones. Let's move on. Now, what do we have here? Well, we have something different here. What do I have in this molecule? Well, I have a ketone, and I have another ketone. What's the prefix we use whenever we talk about two of something? Well, of course, that prefix is di. So whenever we have a diketone, or two ketones, we have to say, well, the suffix here isn't -one, it's dione, because I have two of them. So what's our longest carbon chain? Well, it's 2, 4, 6, 7 carbons, which means heptane. And if we just follow exactly the same logic, we have our parent name in front of our suffix. But can you guys see why we do not need to remove the E from heptane here? And that's because our suffix begins with a D. It doesn't begin with a vowel, so therefore heptane dione. But can you guys see why we are not done with this yet? The fact is, we've said we have two ketones, but we've not said where they are. If we count from whichever side gives us the lowest number for where our ketones are, it's actually from the right side, so that's carbon number 2, 3, 4, and that's 5. So therefore, 2, 5, heptane dione. All right, now let's move over to this one. Now, one thing you might be wondering is, what is CHO? And more importantly, what's that? Is that an alcohol? That's what it looks like, yeah? Well, CHO, you may have seen this before as well, is actually shorthand for an aldehyde. CHO actually means this. So anytime you see CHO, what it means is you have an aldehyde. Except in this case, you have two aldehydes. So what do you think we call a molecule like this? What would the suffix be for the functional group? Well, it would be al, but there's two of them, so it would be dial. Now you guys can guess what the name of this is. I hope. Our parent chain is 4 carbons. So what we have is butane dial. Now we have to be a little bit careful here though, because we actually have more than one choice about what this could actually look like. We could have this aldehyde coming off this carbon as well, but we don't. So in this case, we do need to specify where each aldehyde is. 1, 4, butane dial. All right, let's move on to a more complicated case of these guys. We have another ketone here. We have another aldehyde here. But you can see what else we have complicating the matter. It's what we had when we were first talking about alcohols. We have the presence of the double bond, which makes our naming a little bit more involved. Not that much more, but a little bit. Let's look at the ketone first. What's the parent name? Well, you can see the parent name is pentane. If that double bond wasn't there, you could see the name of that molecule would be 2-pentanone. Okay. So I'm just going to write out here 2-pentanone. But you can clearly see that's not the name of the molecule, because I've got to take into account the double bond. What this means is this isn't 2-pentanone, it's actually 2-pentenone. Why the enone? Well, the enone because of the fact there's an alkene there. All right. This makes naming this a little bit more complex because we need to specify where the alkene is. All right. So if the carbonyl is on carbon number 2 and the alkene is on carbon number 3, then could we say something like this? Could we put a 3 here and say 2-pent-3-enone? Well, we could, but can you think of a way that more clearly defines exactly what the 2 is specifying? The 2, of course, is telling us where the carbonyl is, and this name is okay. One other way to name this is to put the location numbers literally right in front of what they are talking about. So the 3 comes right before the alkene, and so therefore the 2 comes right before the ketone. All right. Okay. Now, unsaturated aldehydes like this are a little bit easier because we've said before, this guy doesn't need a number because it's just there by itself. It's just there, automatically carbon number 1, so therefore whatever else is present, in this case the double bond, is numbered relative to it. So what's our longest carbon chain? Well, it's 2, 4, 6 carbons. So with that double bond, that would be hexanal. So, using exactly what we said here, we know it's not hexanal, it's hexenal, and that alkene starts on carbon 2. So therefore, what we can say is 2-hexenal. Right? One more thing on this guy before we move on to the next structure. I wrote up at the top here 2-pentanone. There is actually another way to name these molecules, and it looks like this. Pentan-2-one, just a different place where the 2 goes. Notice this naming convention is very similar to this one. So if you start with this one, going to here is a little bit easier. So it doesn't really matter whether you do this or whether you do this. Just make sure you know whenever you're naming a molecule like this guy, you want to make sure you have your location numbers specifically in front of what exactly they are specifying the location of. Okay? I hope I didn't confuse you too much. All right, let's look a little bit at cyclic aldehydes and ketones. Cyclic ketones, like this guy, are actually very simple to name. You just name them as you would normally, except you just name this guy, well, you would name it as you would normally name it. So what's a 5-carbon ring? Well, of course, it's cyclopentane. Cyclopentane. Okay. And we know the suffix is -one. So we're going to have to lop off our last E. And so what this means is our name becomes cyclopentanone, just like naming aldehydes, naming ketones the way we just did. Naming cyclic aldehydes, though, is a little bit different. So we just need to get this sorted out right now. The naming convention is slightly different. So notice here we have our CHO, okay, telling us we have an aldehyde. And we have an ethyl group here. The naming convention here involves listing the name of the parent chain, or in this case parent ring, which in this case is cyclobutane. And then the way these are named, the suffix for a cyclic aldehyde, I don't exactly know why it is this way, but it is. The suffix for a cyclic aldehyde is carbaldehyde, just like carbohydrate, carbaldehyde. So what this means is, the name for this is actually cyclobutane carbaldehyde, or at least it would be if this ethyl group wasn't here. Now, we've already said that we know the ethyl group is on position number 1. All right. So we are going to name, or we're going to make sure we understand that by placing the location number of the ethyl group. If the aldehyde's on carbon number 1, what carbon is the ethyl group on? Of course, it's on carbon number 3. So we have our parent name, we have our suffix. All we need now is our prefix. So our prefix here is 3-ethyl. So we have quite a long-sounding name here. 3-ethyl cyclobutane carbaldehyde. Notice we don't need to do anything to the last E here because the suffix doesn't start with a vowel. 3-ethyl cyclobutane carbaldehyde. But is that the actual name? Can you see anything that I've missed here? If you're shouting yes from the back somewhere, well, you would be right. What I'm missing here is, of course, the fact I have a wedge here. Not a wedgie, but a wedge. And a dash here. Everybody's favorite stereochemistry. So what does a wedge on one carbon and a dash on the other mean? Well, it means they're pointing in opposite directions. And what is the one word we use to describe things that are pointing in opposite directions when we're talking about two substrates? The fact is that word is trans. So the whole name for this, it's kind of a long name, trans 3-ethyl cyclobutane carbaldehyde, and that is how we would name these. And that is it for naming aldehydes and ketones. Thank you very much.